So good morning children, this is KG Misra. Again I have come with the next part of the video of second chapter of class 9th, that is force and laws of motion. We have finished the chapter, the theory part we have already finished. Okay. Today we will be discussing the Ncert questions. Okay. And in between, wherever it is required, we will discuss about some important concepts also. Okay. So I hope all of you are well and fine, okay, and taking care of the rules of lockdown and putting your hard work on your studies. Okay. So see, let's go to the first question. Question number 1. Now see, what is question number 1 according to your Ncert? See, questions you have to write by yourself in the notebook. Solution I will giving here. Okay. So first question is that no, an object experiences a net zero external unbalanced force. So how much force is acting on the object? It is net unbalanced, zero force is acting. That means no force is acting on the body. Or you can say whatever forces are acting, that they are balancing each other. Okay. Now the question is that will the body will have some velocity or not? If yes, then what about its magnitude and direction? Okay. And what is the condition for that? If no, then what is the condition? Okay. So the answer for this question is that no. See, according to Newton's first law, what we know, if a body is at rest, then it will remain at rest unless until an external unbalanced force is applied on it. But here what has been told, that no unbalanced external force is applied, zero unbalanced external force is applied. Zero unbalanced external force means what? No unbalanced external force. So if body is at rest, it will remain at rest. And if it is moving in a particular direction with uniform velocity, then what will happen? As zero unbalanced external force is applied, according to Newton's first law, it will continue to move with the same velocity in the same direction. Okay. So what you can write, the answer of first question. Okay. As the net unbalanced force acting on the body is zero, so body can have velocity body can have uniform velocity. Velocity in a particular direction. Okay. In accordance with Newton's first law, law of motion. Okay. So as the net force unbalanced force acting on the body is zero, so body can have uniform velocity in a particular direction. Okay. In accordance means according to Newton's first law of motion. Okay. That is the second part. No? You know that according to first law, no? If body is at rest, it will remain at rest. And if it is having some velocity in a particular direction, then it will continue with the same uniform velocity in the same direction. Okay, so yes, it is possible when net force is acting, unbalanced force is acting on the body is zero, then obviously body can have velocity, but it will have uniform velocity and in a particular direction, and that will not change, okay, during the course of motion, because net unbalanced force acting on the body is zero. Okay, and if the body is at rest, then obviously it will remain at rest. Okay, so you can write yes, it can have. Okay, it can have. Okay, it is possible, and it cannot have also. If it is at rest, then it will remain at rest. So this is the answer of first question. All of you note it down. Now the second question. Okay. Now see question number 2. What is all about the question number 2? Question number 2 is that you have got a carpet. Okay. And you are going to beat the carpet with the stick. You know, carpet is beaten by a stick. So that dust which is present inside in the carpet, no, that will come out of it. Okay. So we used to beat with the stick. Now the question is that why this dust comes out of this carpet when it is beaten by stick. Now see, answer of this question is very conceptual one. Okay. See, when we are beating the stick, no, then the fibers of the carpet, okay, due to getting beaten, the fibers of the carpet, they suddenly come into motion. But what about the dust particles? Due to inertia of rest, they try to remain at rest. See, this is suppose dust particle, this is dust particle, and this is carpet surface. It is sticking there. As this carpet is beaten, the carpet will come into motion like this. As it comes into motion, this remains in rest. What both get separated? Again, it will come, because see, after beating it vibrates, no? It happens like this. It moves like this. So when it is moving like this, then what happens? It gets separated and this falls. Okay. In this way, the dust gets separated. So you can write like this. When okay. So answer is, when carpet is beaten by a stick, then fibers of carpet comes to state of motion. Okay, the fibers will come in state of motion while dust particles remain at rest. So it gets separated from carpet due to inertia of rest. So this is the answer of this question. Second question, please note it down. Noted? Okay. Now question number 3. See, what is this question number 3? Question number 3 is related to the practical thing. You might have seen, no, the buses are going or the trucks are going, then the things are kept, okay, on the over the buses, okay, and the things are tied. The question is that why we used to tie the things over the buses? Why don't we leave as it is? Just we keep over the bus and just keep the things as it is. Now we have to reply this. So the answer is that no, if you are not tying, then what will happen? First scenario, suppose bus is at rest, okay, things are also at rest, and as soon as the bus starts moving, what will happen? Bus will start moving, but due to inertia of rest, the things will try to remain at rest. So what will happen? Suppose this is the luggage which is kept over this bus. This is the bus. Bus starts moving, and this luggage remains at rest. Okay. So what will happen? It will fall. Okay, like this. Okay. So as bus moves, the luggage will fall in the backward direction. Okay. Now second scenario. If a moving bus is there and suppose a moving bus is there and it suddenly what happens? Both are in motion and it stops. Brakes are applied and it stops. What will happen? Luggage will be in the state of inertia of motion and bus stops. So what will happen? Bus is coming like this. See. So it is coming like this. Bus stops and the luggage will move ahead and fall in the forward direction. Okay. Now, not this much only. If the bus is taking turn, suppose it is kept like this, bus is going like this, and bus takes turn like this. So what will happen? What was the direction of motion of this? It was this one. So as it takes turn, what will happen? It will try to go in this direction. So it will fall in this direction. So either when the bus starts moving, or bus is stopping, or it is taking turn. Okay. Then what happens? The luggage will fall due to inertia. Okay. Clear? Okay. So third question. Okay. See, luggage kept on the roof of a bus is tied with a rope because if not tied, when bus starts from rest, then due to inertia of rest, see, when bus starts from rest, what will happen? Bus will come in motion, but the luggage will remain at rest. Okay, so due to inertia of rest, what will happen? Luggage will fall behind the bus. So bus will move ahead and the luggage will fall there only. Okay, behind the bus. Now second part, if the moving bus stops, then due to inertia of motion, see, bus has come to rest, but luggage is still in the inertia of motion. So what will happen? As this is luggage and this is bus, luggage is there on the bus. As the bus is going and bus stops, luggage will go ahead and fall in front of the bus. Okay, so it falls in forward direction, falls forward. Okay, if bus takes turn, then luggage will fall. Due to inertia of direction. Okay, so luggage will fall. Remaining I will write. First note down this much. Written? Okay, I'm going to complete this. Luggage will fall due to luggage will fall aside due to inertia of direction. Okay, so these are the three cases in which the luggage will fall when you are not going to tie the luggage, okay, which is kept on the bus. Okay. So that's why what we prefer to tie it, because we don't want the luggage to fall from the bus. Okay, noted? Okay. Now see, the fourth question is that a batsman is there, okay, and batsman hits the ball. As batsman hits the ball is going to roll on the plain ground, okay, and it is rolling. After rolling some distance, what happens? It gradually slows down and finally it comes to rest. Okay. Now the question is that there are four options are given. Which of them is the appropriate reason for this? Now see, it is stopping due to the batsman did not hit the ball hard enough. Is it like that? If the batsman will hit the ball very hard, so it will never stop. Is it like that? It will also stop, no? So obviously this is not the appropriate reason. Now this one, the velocity is proportional to the force exerted on the ball. So that means if more force is applied, then it will move with more velocity. Then it will not stop. It will never stop. Is it like that? Obviously, if more force you are applying, more velocity it is having, then also it will stop, no? Have you seen any batsman hitting a ball with lots of force? It never stops. Is it like that? It also stops. That means this is also not appropriate. There is a force on the ball opposing the motion. Yes, this is the reason. Because see, if a ball is moving in the forward direction, then there must be some opposing force. That's why it is stopping. Now, which is that force? Obviously, you have studied in class 8th. It is the force of friction, which opposes the motion of the ball. Otherwise, if that friction force is not there between the ground and the ball, then what will happen? According to Newton's first law, if a body is moving with uniform velocity, then it will continue to move unless some external unbalanced force is applied. So ball will never stop and keep on moving. Okay, but there is an opposing force, and that force is friction force. Okay, let's see the fourth option, but we got the answer. Okay, then also let's go to the fourth option also. there is a no unbalanced force on the ball. No unbalanced force is acting on the ball. So ball would want to come to rest. So ball wants to come to rest. Is it true? But then what is inertia? Inertia says that if a body is in motion, then it tries to continue in the motion. Okay. If no unbalanced force is acting, then ball should never stop. How it can try to come to rest? So because of inertia, it should never stop. But it is stopping. So this is also not appropriate reason. Okay. So this is the appropriate reason. The ball is stopping because of the opposing force, and that force is frictional force. Got it? Note it down. Okay. Now let's go to the question number 5. See, what is question number 5? See, there is actually a hill is there, okay? And on the slant of hill, there is a truck. Okay, there is a truck is there. Okay, a truck is there. Like this. Trucks are like this. No? Truck is there. And it is initially at rest. Okay, and then it starts rolling down. And when it is rolling down, it is moving with constant acceleration. But acceleration is not given. It is given that it is going to move with a constant acceleration. Roll down with the constant acceleration. Okay. And it covers 400 meter distance in 20 seconds. Okay. The truck is there on the slant of the hill. Its initial velocity is 0. And it rolls down with constant acceleration such that it covers 400 meter in 20 seconds. What we have to find out? Acceleration. And we have to find out force also. For finding force, they have given extra information. That is, mass of the truck is 7 tons. 1 ton is how much? 1000 kg. So 7 ton is equals to how much? 7000 kg. Okay. Now we can go for the solution part. Okay. I think you have understood the situation of the question. Now, you want to find out acceleration. Okay. U is given, S is given, T is given. Which formula we should use? Obviously, S is equals to, but S is equals to UT plus half AT square. Okay. Now S is how much? 400 meter. U is 0. Time is 20 plus half. A we don't know. Time square. Time square means 20 square. Okay. Clear? Now see. This is 400. This part will become 0. Here what will we get? Half A. 220 square is how much? 400. We can cancel this 2 with 400. What will we get? 200. Okay. Now A is how much? 400 upon 200. So what will we get? 0 0 cancels out. 0 0 cancels out. 2 2 ja 4. So A is how much? It is 2 meter per second square. Got the answer? Acceleration is 2 meter per second square. First part you have done. Acceleration we have got it. Now second part, we want to find out the force. Now what is force? According to Newton's second law, what we know? F is equals to mass into acceleration. What is mass? It is 7000. Acceleration is 2. So what is the force? 14,000 Newton. Okay. So in this way we can get the force also. Got both the things? Note it down. This is given actually. And this is your solution. Okay. See, now this is question number 6. What is question number 6? Just see here. Actually, in the cold place actually is there, okay, and ice is frozen. You know, when ice is frozen, then what will happen? It will behave like a solid surface, and you know ice is more smoother than the soil. Okay, so this is very smooth surface. Okay, and what you are going to do? You are going to throw a stone along the surface. What is the mass of the stone? It is 1 kg. With what velocity you are going to throw it? With a velocity of 20 meter per second. And what has been observed, by the time the stone travels a distance of 50 meter, it comes to rest. That means final velocity becomes 0. Okay, clear? Here velocity was how much? 20 meter per second, and here velocity becomes 0 meter per second. Okay, so we get from here what we get? We get velocity, final velocity is how much? Final velocity is 0 meter per second. Okay, now why it has come to rest? The stone, again because of friction force acting between the stone and the frozen ice surface. That friction stops it. Okay, now we have to find out that force. Okay, that is our question. So let me remove this diagram first. You've understood, I think. Now we will solve the question. So given is written that side, solution starts from this side. We have to find out the force. Okay, now can we find out the acceleration? Yes, we can use the formula v square is equals to u square plus 2as. Okay, v is how much? It is 0. Square again 0. Okay, no problem. Okay, 0 square. U is how much? 20. So square of this plus 2. A is, we don't know. S, it is how much? S is given 50 meter. Okay, now this is 0. Okay, no problem. 20 square is how much? It is 400 plus 50 into 2 is how much? 100A. Okay, now if we take this 100A this side, what will we get? Minus 100A is equals to 400. So A is equals to how much? 400 by minus 100. Okay, 0 0 can cancel out. What will get? A is equals to minus 4 meter per second square. So why it is coming negative? Because it is retarding force. Okay, it is retarding force, and this acceleration is retardation, and we know that retardation comes in form of negative. Okay, when you are getting answers like this, okay, and if you are writing retardation, suppose you got this answer and you are writing retardation. Okay, or you are writing minus a, because minus a is retardation, then you have to write 4 meter per second square. Okay, when you are writing acceleration, then you will write minus 4 meter per second square. Remember, when you are writing retardation, then you will write plus 4 meter per second square, because retardation means already there is a minus. Clear? Okay, so you got this, but you have to find out force. Why you have got this? See, just note it down first, then I will tell you. Noted? Okay. So we got the acceleration minus 4 meter per second square. But we have to find out the friction force. So this retardation occurred due to the friction force only. So we can find out from Newton's second law, force is equals to mass into acceleration. Mass is how much? 1 kg. Acceleration is how much? Minus 4 meter per second square. So what you will get? Minus 4 Newton. What does this minus sign indicates? This minus sign indicates that it is the opposing force, or because friction opposes the motion, no? That's why the negative sign is coming. Okay, so if you are writing opposing friction force of 4 Newton is acting. As I have written opposing, so I have not put the negative sign. If you are not going to write opposing, then you have to write friction force is minus 4 Newton. Okay, so this is the solution of question number 6. Okay, see in question number 7, what is there? In question number 7, see, it is there. a train is there. Okay, this is the engine. Okay, this is the engine, and these are the wagons W. Okay, this is first wagon, second wagon, third wagon, fourth wagon, and fifth wagon. Bogies we call as wagons. Okay, now what is the question? This E for engine. So engine, what is the mass of the engine? It is 8,000 kg. It's very less, no? What is the mass of each wagon? It is 2,000 kg. So it has got 2,000 kg. This also, this also, this also, this also. All are 2,000 kg. Each of them has mass 2,000 kg. W for wagon. E for engine. Okay. Now number of wagons, how many? 5. You can count 1, 2, 3, 4, 5. Okay. The engine is applying force of 40,000 Newton. Okay. How much force this engine is applying on these wagons? It is applying 40,000 Newton. Okay. Remember, who is applying force? Engine is applying on these wagons. That means here how much force is acting? 40,000 Newton. Okay. And now, what is this? This F, small f means friction. Force of friction between the wheels of the wagon and the railway track is how much? 5,000 Newton. Okay. And we know that friction force always opposes the motion. Now, this is the given data. Now, what is the question? First part, what is the accelerating force? Accelerating force means what is the net force which will be responsible for motion of the train. Okay. So now, if you want to find out the accelerating force, then what we have to do, let's see. Second part, we have to find out the acceleration of the train, and third part, we have to find out the force on wagon, force of wagon 1 on wagon 2. That means how much force this wagon 1 is going to apply on wagon 2. Okay, because this engine is pulling this wagon, and this wagon is pulling the second wagon is pulling third is pulling fourth is pulling fifth. In this way, the whole train is moving. Okay, so how much force 1 is going to apply on 2? That has been asked in part C. Okay, so let's go to the first one. First part, what is the net force that you have to find out? So net force is Fe minus F, that is friction force. How much force engine is applying? Engine is applying 1, 2, 3, 4, 40,000. How much the friction force is acting? It is 5,000. How much you will get? 3,500 or 35,000. 35,000 Newton. This much force will be acting. This is the net accelerating force. Okay. Now, the second part, we have to find out the acceleration. In case of acceleration, we know that F is equals to ma. Okay. Now here A is equals to what? Force by mass. Now, this net force is acting on which part? This is acting on this part, not including engine, because engine has applied this force. So this force 35,000 Newton is acting on this wagon part. Okay. So here what you have to take? You have to take the mass of the wagons. How many wagons are there? 5. What is the mass of 5 wagons? When the mass of each wagon is 2,000 kg. So mass of 5 wagons is how much? Yes. M is equals to 5 mW, because 5 wagons are there. So 5 into 2,000 kg. How much will get? 10,000 kg. Okay. So that we have to put over here. So we'll get acceleration is equals to force is 35,000 upon mass is 10,000. So you can cancel 1, 2, 3. 35 by 10 is how much? A is equals to 3.5 meter per second square. That is the acceleration. Acceleration is 3.5 meter per second square. Okay. This 10 we have used to shift the decimal from here to here. That's why we are getting 3.5. Okay. Now what is the next we have to find out? We have to find out the force which wagon 1 is exerting on wagon 2. This is little bit tricky. Okay. Not very tricky, but little bit tricky. Done this much? Okay, I'm going to rub and I will explain you the C part. Remember this acceleration, 3.5 meter per second square. See, this is wagon 1, suppose. This is 1. And this is going to apply force on wagon 2. Okay. Now, see here. How much force is acting on this? It is acting, you know very well. Okay. How much force is acting on this? That you have to find out. Okay. See, in part C, we have to find out force exerted by the first wagon on the second wagon. Clear? Now see, we know that the total force applied by the engine after removing that frictional force is how much? It is 35,000 Newton. Okay. That is the force which is causing acceleration. Now, when it is moving in this direction due to this force, it will pull this in this direction. And as it is going to pull in this direction, this will also pull this in the backward direction with the same force, because action reaction force will be acting. This is going to give action to this in this direction. And this is going to give reaction force to this. In which direction? Towards it. Okay. It will pull this towards itself and this will pull this towards itself with certain force. Let that force is F. This force we have to find out. Okay. Now, whatever force this wagon 1 is applying on the second wagon, due to that force only, all these 4 wagons are moving with the same acceleration of 3.5 meter per second square. Okay. Clear? So, we have to find out that force. Now, we know that this force F is how much? It is m into A. Now, A we know very well because all are moving in the same acceleration, that is 3.5 meter per second square. Okay. Now, what about this mass? We have to take the mass of 1, 2, 3, 4 wagons. Okay. Because due to this force only, all the 4 wagons are being dragged with the same acceleration. So, what is the mass of one wagon? It is 2000 kg. So, what is the mass of total mass of 4 wagons? 1, 2, 3, 4. 4 into 2000 is how much? 8000. Okay. And then we will get force how much? Force is, you can multiply this, you will get 28,000. Okay. Newton. But here, for your convenience, you can write m is equals to, or you can write here, m is equals to 4 mw. That means 4 times the mass of wagon. That is 4 into 2000. That is 8000 kg. Okay. F is equals to ma. How much mass is being dragged due to this force? It is 8000. How? Because m is equals to, these 4 wagons are being dragged due to this force. So 4 into mass of one wagon, that is 4 into 2000, that is 8000. That's why we are writing 8000 here. What is the acceleration? The acceleration of whole train is same, that is 3.5 meter per second square. Already we have calculated. And mass into acceleration is force. And how much we are getting? 28,000 Newton. Clear? Okay. See, in question number 8, what is there? In question number 8, a vehicle is there. Okay. This is the road. A vehicle is there. Okay. We can take any vehicle. Okay. It is not specified over here. We are taking a vehicle. Okay. And it is moving with certain velocity u. We don't know what is this velocity. Okay. And its mass is given m. M is how much? That is 1500 kg. And then a negative acceleration is applied. Okay. Negative acceleration means obviously you are applying the brake. So retardation is acting. So we can write it what? We can write this is equals to minus 1.7 meter per second square. Okay, we can take this minus that side. So retardation is acting. And then finally it comes to rest. Now what we have to find out? We have to find out, because as it is coming to rest, that means it is coming to rest due to the friction. Okay. Even when the brakes are applied, then also due to friction only it comes to rest. So what is the frictional force between the road and the wheel, that we have to find out. Okay. If there is no friction, then what will happen? Even if you are applying the brake also, then also it will keep on sliding. Okay. And like people do in skating, no? ice skating, you might have seen. In the same way, this truck will start skating on the road and will never stop, according to Newton's first law. So it is not the case. Here actually friction is there, that's why it comes to rest. So we have to find out the force. Now, for finding force, it's very easy. F is equals to what? It is mass into acceleration. So mass is how much? It is 1500. Acceleration is minus 1.7 meter per second square. Multiply this. We have got two zeros, 1 0, 2 0. Okay. Now 15 7 ja 105. So you will get 5 and 10 is your carry. Okay. 15 1 ja 15. You have to add 15 to this carry. You will get 25. And decimal is after one place. So how much you are going to get? 2550 Newton. And this negative sign, where the negative sign has gone? It should be here only. Why this negative sign? Because it is opposing force. Okay. I should remove this calculation part. It is like this. Okay. Note it down. Noted? Okay. So my dear children, we have solved till question number 8 of Ncert. Okay. With the remaining question, I will come with the next part of the video. Okay. Till then, just keep on trying and take care of yourself. Thank you.